Alright, you guys, so we're going to go ahead and move on to lesson 5.4. And in this case, guys, lesson 5.4 talks about the recursive formula in arithmetic sequences. Students in this case can determine sequence features using the recursive formula. Arithmetic in this case, guys, talks about, well, we'll actually talk about it right now, so I won't get ahead of myself. But just a few of our vocab terms here is arithmetic sequence, recursive form, and common difference. So starting off in this case, guys, what is an arithmetic sequence? Arithmetic sequence in this case, guys, it's basically saying going from one term to the next by adding or subtracting. So arithmetic in this case focuses on a sequence where you're either adding or subtracting to go from one number to the next. All right. And here's just a few examples, guys. If I want to go ahead and identify the sequence of, let's say, number 1 here. And in this case, I have 2 as my first term. Then I go 5, 8, 11, 14, and so on. Question for you guys is, how am I going from one number to the next? What am I doing in this case? By how much is it changing each time? And in this case, guys, how do we go from 2 to 5? We're actually adding 3. From 5 to 8, we're also adding 3. 8 to 11, adding 3. And 11 to 14, we're adding 3. So that's the sequence there. You know, we're adding 3 each time to get to our next number. If we take a look at the next one, in this case, we have 7, then 3, -1, -5. So once again, it's called the sequence when it's the same pattern repeated over and over. So in this case, how do we go from 4 to 7? For 7 to 3, would be actually subtracting 4. And then from 3 to -1 is subtracting 4. And then from -1 to -5 is also subtracting 4, and so on. So that's just, you know, a sequence there, and that would be considered an arithmetic sequence because we're either adding or subtracting to get from one number to the next. So let's go ahead and check this out. So in this case, guys, talking about recursive formula, it's basically saying it's a formula for the next term depending on the previous term. All right, and what we need in order for us to actually write a recursive formula is, first thing is we need the first term. The first term of the sequence, it's first number you're given in any sequence, and the common difference in this case is by how much it's changing each time. So how you go from one number to the next, that would be considered the common difference. So let's go ahead and check this out, guys. Let's go ahead and get started here first with example 1. It says below is the recursive formula for the sequence. And we have A1 equals 3 and AN equals A parentheses n minus 1 plus a 2. Now, first thing they're telling you guys here, A1, these A's, you see, all the A's you see here, those do change based on whatever it's given to you. It could be a B, it could be a C, it could be an X. It really doesn't matter. So, in this case, guys, the first thing they're giving you, A1, represents the first term. It represents the first term of the sequence. All right, A1 in this case represents the first term of the sequence. And in this case where we have A of n, this number here represents the common difference, which is by how much it's changing each time. Common difference. All right. So in this case, the question here, or what I want to find, is the fifth term of the sequence. All right. So I have my first term, and then moving on to the next one. And I'm just going to draw 5 lines here. So my first term in this case of the sequence, first term of the sequence here, guys, is a 3. Now, if I want to go from one term to the next, I have to add 2. So what's 3 plus 2? 5. If I want to go on to the next one, I have to add 2 again, which would give me a 7. Then moving on to the next one, add 2. Gives us a 9. And then if we add 2 again, it gives us 11. So then our fifth term here, or a of 5, is 11. All right, a of 5 would be 11 there. All right, let's go ahead and check out the next one. And here's example 2. It says find b of 4 in the sequence given by b of 1 equals -5, b of n equals b n minus a 1, plus a 9. So in this case, guys, we do want to go ahead and find b of 4, which is the fourth term of the sequence. So let's go ahead and first identify what's given to us. So -5 in this case represents our first term. And in this case, the 9 represents a common difference. Common difference. All right. So in this case, guys, if we want to find the fourth term, once again, let's go ahead and just draw 4 lines here, because I'm only looking for 4 terms. My first term in this case, guys, is -5. And by how much it's changing each time is that I'm actually going to be adding 9. Adding 9 to the previous term. So -5 plus a 9 would give us a 4. And then once again, add 9, that's 13. And add 9 again, that's 22. So b of 4 is 22. All right. Now each time, guys, once again, we were adding 9. All right. Let's go ahead and take a look at the last one here. Writing a recursive formula. So here's my sequence of 5, 8, and 11. And I want to go ahead and write a recursive formula here. Now, in this case, guys, with recursive formula, all you need is your first term and the common difference. So if I write this down, let's say I just write this as b of 1. b of 1 is going to represent what's my first term. And in this case, guys, what is our first term here? First term in this case is a 5. Now I'm going to go ahead and write the common difference, which is b of n equals b times n minus 1. And in this case, guys, how am I going from 5 to 8 to 11? By how much it's changing? So from one point, let's do a different color. From one point to the other, let me move this up. So from here to there, we're adding 3. Here to there, we're adding 3 again. So in this case, I will have to put a plus 3 there. So my answer here would be 5, which is the first term, and 3, which is a common difference. And this is actually how you'll be seeing that on Khan.